Screen cut off. Okay. All right. Hyperbolas are going to have one teeny tiny difference in their equation between ellipses and hyperbolas. But it is going to make the graph look so much different. Okay? So what's happening here, what we're going to see happen, Desmos should be coming up. Come on. Okay, so this is what's going to happen today. Okay? As far as putting these in standard form, it's going to be almost the same. Almost the same. Everything you do to put it in standard form is going to be basically the same as an ellipse. But if instead of a plus right here, I have a minus, look at what it does to the graph. Yeah. It's crazy that a little. Yeah, it is like a little bit like a rational term. So that one sign changing makes a huge difference in what the graph looks like. And this is what a hyperbola is going to look like. So, yes, they go on forever. Here. There are a lot of things that I could make you learn how to do with a hyperbola. But due to the fact that we do not have an immense amount of time to look into this, nor do I think it's beneficial for you to memorize a lot of formulas and find all of the stuff if we're not going to do anything with it, because we really don't have time for like a lot of application here. We're going to learn some things about a hyperbola, but not tons. Okay, so the vertices of a hyperbola are going to be these two sort of turning points of the graph. We call the axis that goes through those two vertices, that's our transverse axis. This vertical axis right here, it's vertical on this one, the one that goes between the two pieces of the graph, that's called our conjugate axis. And then hyperbolas are going to have slant asymptotes. So it is a lot like a rational that's been turned on its side. It's like you kind of took the x and y axis and turned them, right? And so the asymptotes are slanted in this case. Okay, we could go into a great amount of detail finding all of this stuff, but we're going to go with sort of a general version of this. So, the standard form of a hyperbola that opens left and right. Always get mixed up. Okay. If your x is positive, your graph is going to open left or right. So it would look like this. X minus h squared over a squared minus y minus k squared over b squared equals 1. So again, that one difference that we see between the formula for this and the formula for the ellipse is just that negative right there. That's our only difference. The center of this, just like with circles, just like with ellipses, is going to be HK. Okay? If you have a hyperbola that opens left and right, so the center would be right here. Okay? If you have a hyperbola that opens left and right, then your vertices are going to be to the left and right, so you got to change the x coordinates. It would be h plus or minus a, and then the k would stay the same. So we're talking about this point right here and this point right here. This distance right here is your a, right? That distance from the center to the vertex is that a value. And then your transverse axis is the axis that actually goes through those vertices. It is horizontal, so it's going to be y equals the y coordinate, which would be k. These are the only things I'm going to ask you for these. Okay? I could make you find slant asymptotes. I could make you do a lot of different things, but we are not going to do those for these just because it can get pretty intensive for that. All right, so we will finish these notes tomorrow. There is no homework tonight. Please think about the arch problem. See if you can figure it out. It's really cool if you do. Yes.
They all look like rhombuses.
Yeah. They're kind of hard to draw. Okay, thank you.
Do I need to keep this?